All right, today we're diving into an idea that could completely change how we build AI. Seriously, what if the biggest problem in artificial intelligence isn't the algorithms at all, but the very language we force them to speak? A new paper proposes a solution called Tensor Logic. And you know what? It might just be the breakthrough we've all been waiting for.
Look, we've all seen how incredible modern AI can be, but we've also seen its weird, frustrating flaws. You ask a chatbot a simple question, and it just confidently makes up a completely fake answer. These hallucinations, as they're called, are a massive problem, right? They kill trust, they make the tools unreliable. But what if the real problem isn't the AI, but the language it's built on?
You see, here's the thing. At the root of it all is a simple fact. AI doesn't have its own native language. We're building these unbelievably complex systems using programming languages like Python. And listen, Python is great, but it was never ever designed for AI. It doesn't have built-in tools for things like logical reasoning, which forces developers to create these messy, expensive workarounds. It really is like trying to build a skyscraper with tools designed for making a wooden chair.
So, for decades, AI has basically been a field with a split personality. On one side, you've got Symbolic AI. It's all about logic and rules, so you can actually see how it thinks. It's transparent, but it's super brittle and a nightmare to scale up. Then on the other side, you've got deep learning, the powerhouse behind all the big models today. It's amazing at learning from data, and it scales like crazy, but it's a total black box. And yep, it's the one that hallucinates. For years, we've been forced to choose logic or learning. You couldn't have both.
And this isn't just some minor technical inconvenience. The author of this paper, Pedro Dominguez, absolutely nails it with this quote. A proper language, it changes everything. It focuses a field. It unlocks totally new ways of thinking. Think about it. Physics exploded with calculus. Digital circuits took off with Boolean logic. AI, it's still searching for its own fundamental language.
And that brings us to the breakthrough. This is where it gets really, really cool. What if these two warring ideas, this strict, rigid logic, and this flexible, messy learning, what if they aren't opposites at all? What if they're actually two different ways of describing the exact same thing? Okay, so first, let's look at the old school symbolic side of things. Here we have a classic logical rule. It defines what an ancestor is. It's precise, it's symbolic, and it's perfectly logical. If the conditions on the right are true, then the conclusion on the left has to be true. It's a clear, unbreakable rule. Simple.
Now let's jump over to the other world, the world of deep learning. This is a fundamental math operation that neural networks use all the time. And it looks completely different, right? It's not dealing with words like ancestor or parent. It's all about crunching numbers in these things called tensors. And you can just think of tensors as grids of numbers, kind of like a spreadsheet that can have a bunch of different dimensions.
Okay, get ready for this, because this is the big reveal, the absolute core idea of this entire paper. The researchers are proposing that a logical rule is just a tensor operation being performed on tensors that are filled with true/false values. That ancestor rule we just looked at, it turns out it is mathematically identical to a tensor operation. They are the same thing, just expressed in two completely different languages.
So once you have that massive realization, what happens next? Well, you get a whole new language for AI, Tensor Logic. It's a language where logic and math, where rules and deep learning are finally unified. For the first time, these two sides of AI can speak the same dialect, because it turns out, at their very core, they always could.
And what's so elegant about this is how cleanly it all just fits together. I mean, look at this. All these concepts from totally different corners of AI, from probability, from logic programming, they all just snap into place. They map directly onto simple tensor operations. It's like we found a Rosetta Stone for the entire field of artificial intelligence.
And if you want a real-world example of just how powerful this is, look no further. The architecture behind something like GPT, these models that are mind-bogglingly complex, you can write the whole thing out in about a dozen lines of tensor logic. 12? That's just wild. It's an incredible reduction in complexity.
Okay, so this is all very neat, very elegant, but what can you actually do with it? Well, this is where we get to what might be Tensor Logic's killer app, a potential cure for AI just making stuff up.
So here's how it works. Tensor Logic lets AI reason in a totally new way. It represents facts and rules as points on a giant, multi-dimensional map. And get this, logical steps just become simple math operations on that map. But the really clever bit is this. You get a temperature dial. If you turn the temperature down low, the system performs pure, strict logic. Turn it up, and it gets creative, making flexible connections, finding things that are close to each other on the map.
And when you turn that dial all the way down to 0, boom. The system's reasoning is guaranteed to be sound. It can only make deductions that logically follow from what it knows. It literally cannot make things up. This gives you the reliability of old-school logic with the power and scale of modern deep learning.
And this, as the paper points out, is a huge deal. It's a fundamental difference from the large language models we use today. You can set an LLM's temperature to 0, tell it to be as uncreative as possible, and it can still hallucinate. Tensor Logic, when it's set to pure logic mode, simply can't. This finally gives us a path toward AI that is both incredibly powerful and fundamentally trustworthy.
So what does this all mean? Where do we go from here? If this whole approach really holds up, what does the future of AI actually look like?
Let's just wrap this all up. What we're looking at here is more than just another paper. It's a potential blueprint for the next generation of AI. We're talking about a unified language that could finally heal the big divide in the field. It's a potential cure for hallucinations and the whole black box problem. It could give us systems that learn like a neural net, but think with the reliability of a logic engine. And best of all, it creates transparent systems where we can actually follow the reasoning. That's the whole package.
So, I'll leave you with this final thought. Tensor Logic is this incredibly powerful, elegant idea. It seems to solve some of the deepest, most fundamental problems in AI. But is that enough? Can a new language, no matter how good it is, overcome the sheer momentum of all the tools and systems we already have? What do you think is the biggest hurdle standing in its way? Let us know what you think down in the comments. We'd love to hear it.